Continuing on with probability, I'll talk very briefly about conditional probability. Conditional probability basically takes, well, in a nutshell, takes your population at large that you are interested in, and it creates a subpopulation. So it's the subpopulation of people or items or events or animals, whatever it is, subjects, that you truly do care about, like you already know something has occurred. Then within that population, the probability of something very specific happening. So we'll take a look back and kind of look at this colorblind question that we've done previously. So we do have a certain population, 60% are male, 40% are female, and then 8% and 3% respectively are colorblind. So under the probability that a male is selected given they are colorblind. Okay, so sticking with some notation here, so probability of male given that they are colorblind. What this is saying is that we know the population that we are concerned with is the population that has been identified as colorblind. So on the bottom, I'm going to put the probability of colorblind. So I'm going to take my entire group of people or population of people from my diagram above, and I only care about the ones that are identified as colorblind. So I'm going to go to the ends of the branches where I see colorblind, there and there. Those are the only ones I really care about. So I'll go ahead and highlight to get back here and highlight to get back here. So this is my whole subpopulation I'm talking about. At this point, I'm not interested in the rest of the branches. I'm only interested in those two. So probability of colorblind, well, could be from the top branch, which is 0.048, or could be from that bottom branch, which is 0.012. Now, of those two branches, again, we're ignoring the other ones now. Of those two branches, we want to know which one represents male. So we're now talking about the probability of male and colorblind. So we've already determined colorblind. So we have our subpopulation here, so only the yellow highlights. And then we find that single branch that is actually male and colorblind. So male and colorblind. In this case, it's that top branch. That's going to represent the numerator of this. Now, as a reminder, we're going to go ahead and have to add the denominator together. So that's going to give us 0.06, and then 0.048, and now we can go ahead and divide those. And as a reminder, this has to be less than or equal to 1, but greater than or equal to 0. In this case, it looks like we're going to get 0.8. So if we know somebody is colorblind based off of this information, what is the probability that that person is also male? Well, that's going to be 80% or 0.8. Okay, it's the probability of being colorblind given that the person selected is female. Okay, so what's the probability of colorblind? But we know the person is female. So we're going to go through and we're going to do the exact same thing. So we still have our diagram up at the top, kind of cleaned it up a little bit. We're now only thinking about our subpopulation here of female. So the probability of female, so it's the conditional part, like what we know has already happened, so the given portion. So I'll go through and I'm going to find all the branches that represent female. So all the branches that represent female, all of them. Those two branches are going to represent the probability of being female, which is 0.012 plus 0.388. Now, of those two branches, we want to know where the intersection of colorblind and female occurs. So this is the probability of colorblind intersected with female. So we find the branch of those two, so we're not looking at the rest of them anymore, that is the intersection of the two. So I want to find female and colorblind. Well, that's going to be 0.012. That's what goes on the top. And then we go through knowing that we have to add the bottom. And we're going to get 0.4, which we should have, because we were told at the beginning that the probability within the group of being female was 40%. So now we're going to take the 0.012 and we're going to divide it by 0.4. This is going to give us 0.03, which makes sense because if you take a look back, female and colorblind, that's the same thing as that 0.013 on the branch.